All right, so in this video, I want to continue the dot product idea that I was talking about. Please make sure you've watched the dot product video before this one. And I want to derive the equation of a plane. And so we're starting with this same vector 1, 3, 5, although that's completely arbitrary. It could be any vector. And what I want to start doing is creating vectors that are perpendicular to it. And perpendicular means the dot product is going to equal 0. So let's say that I have my vector of 1, 3, 5, and I'm going to dot that with some other vector here. And I can choose whatever I want for, let's make the x coordinate -1, let's make the y coordinate 2, and then we'll figure out the z coordinate. And so this is going to be 1 times -1 plus 3 times 2 plus 5 times z is equal to 0. And this is solvable. It's equal to 0 because that makes it perpendicular. And this is solvable for the letter z because we'll have 5 plus 5z equals 0. So z is going to equal -1. And what you're going to see as I type in this new vector, I'm going to go -1, 2, -1, hit enter, and it pops out. There we go. And we can see that that vector is perpendicular to our original vector. Now I could have done this. I can do this as many times as I want. Let's do just one more example just so you kind of get a feel for it. We're going to do 1, 3, 5. Let's say I don't know the x coordinate this time, but the y coordinate is 3 and the z coordinate is 2. Then I'm going to have 1x plus 3 times 3 plus 5 times 2 equals 0. So x should equal -19. And let's type that thing in there. So vector, what do we got? -19, 19, comma 3, comma 2. Hit enter on it, and you can see that that new vector is also perpendicular to our original vector. Okay, and so what we're ending up with is we're starting to see that there really are an infinite number of vectors that I can find that are all perpendicular to the original vector. And so what we do when we start talking about a plane is we talk about all of the vectors at once that are perpendicular to a given vector. So what I'm going to do is clear the screen here, and instead of finding a specific perpendicular vector, I'm going to find the equation of all the vectors that are perpendicular. So we say 1, 3, 5, dot with a arbitrary vector, x, y, and z. And we know that that is going to have to equal 0. And then we come up with this wonderful equation. 1x plus 3y plus 5z is equal to 0. And if I type that equation in to my grapher here, move my little face out of the way, 1x, I guess the 1's redundant, 1x plus 3y plus 5z equals 0. What you'll notice is that this plane right here touches both of the perpendicular vectors that I found. And the original vector of 1, 3, 5 is perpendicular to the plane. We call it normal. The normal vector of 1, 3, 5 is perpendicular to the plane. So I hope you see how this process can be reversed. If you are given the equation of a plane like this, you can extract the normal vector by just taking the x coordinate, the y coordinate, and the z coordinate and saying, oh, I know that 1, 3, 5 is normal to the plane. Okay, so we'll call it good for there right now. I'll make a second video where I do this slightly more generally, but that is pretty much what you need to know about the dot product and about planes.